Hello everyone and welcome. My name Mustafa Omarin. In this video I'm going to explain the C code I've written for my FPGA project, and I will also demonstrate how the push button controls the leads on the board. So this project is running in NEOS2 software. This is Eclipse NEOS2 software, and I'm using the bio modules, one for reading push button inputs and one for driving the lead output. I also use Avalon timer. This is Avalon timer to create half-second delay. So let me start by explaining what the code does in general. Now let's go through the important part of the code. First, I have function called delay half second. This is a function delay half second. This function uses the hardware timer when it starts. This function uses the hardware timer when it starts. The timer counts clock cycle. Since my timer runs at 50 megahertz, half a second is 25 million cycles. So the function keeps looping until the timer reaches that value. I use this delay so that the button press is sampled slowly and doesn't increment too fast. In the main function, I start by clearing the leads. I set the leads bio to 0, so all leads are turned off when the program starts. Then, inside the infinite loop, the program continuously reads the push button. The push button is active low on my board, which means that when I press it, the value becomes 0. So what does it mean? If the bottom value is 0, meaning the bottom is pressed, then the lead counter increases by 1. I also apply a mask. To keep the value inside the range of 0 to 15. Then I write this value to the lead bio, so the leads update immediately. I also print the value to the console so I can see the counter increasing in real time. We will see that. Then after updating the counter, I call the delay function to slow everything down. After updating the counter, I call the delay function to slow everything down. Finally, the program waits until the button is released. This prevents multiple increments from one press, and it also helps avoid switch bouncing. Overview of the program. The idea is simple. Every time I press the push button on the FPGA board, the lead increases like a counter. The counter goes from 0 to 15. I will see now 1, 2, 3. We'll see what will happen to 15. Now 15. We'll see what will happen now. Again to 0, because I'm using only 4 bits, and then it wraps around back to 0. The leads are active high, so whenever the counter changes, the leads display the binary value of the counter. Now let me show how it works on the FPGA board. Here my development boards. This is the push button. I will be using and there are leads connecting to the leads bio. Right now all leads are off because the counter is at 0. When I press the button, what will happen? We will see now. This button. So you can see the leads increasing like a binary counter. Now it will be 1, 2, 3, and so on. We will see what will happen in the final. It will be after 15. Now it's 0 again. Now our program working good. Yes. So we are here again to explain interrupt system in my program. So first of all, this is my code which I wrote in Eclipse again to see the interrupt systems in my FPGA board. So program start and initialization. So this confirms that the system is running. We declare a global count by using static integer counter button. Here we can see we disable the bottom interrupt temporarily. This prevents accidental triggers while the setup is in progress. And the edge capture registers may contain leftover signals. Cleaning it ensures that the system starts fresh. Register the ISR. This links the bottom hardware to our ISR functions. Handle button interrupt. From now, pressing the button triggers the ISR automatically. We will see here. Exact. Here we can see enable button interrupt. Now the button interrupt is active, ready to respond to the presses. Actually, this is the main loop. The main loop continuously prints the counter value. It also updates the leads to show the current counter in binary. The small delay makes leads changes visible to the human eye. So the last part in my code is called interrupt service routine, ISR. So by using this routine, it ensures when the button is pressed, the ISR runs automatically and it increments the counter by 1 and keeps it between 0 to 15. Then it clears the edge capture flag, so the system is ready for the next press. As we can see, each press of the bottom increases the counter by 1. The leads show the counter in binary 0, 1, 10 until 1, 1, 1. After 15, the counter wraps back to 0. So this demo shows how interrupts works and how use PAYO for interrupt for input output, and how the FPGA responds instantly to hardware events. Thank you for listening.